Let's look at two more when we are adding or subtracting, just to get a bit of practice. So what about if we have something like find all the solutions to tan x plus 73 equals 1.84. So we haven't looked at tan, so let's just have a example with that one. So we've got tan bracket x plus 73 equals to 1.84. Okay, and we are in the interval between 0 and 360. We have x plus 73 equals to tan minus 1 of 1.84. So you have x plus 73 equals to 61.476. First steps first, change our interval because we're dealing with x plus 73, guys. We're just going to add on 73 to either side of the interval, so it's 433. All right, so that's our interval. Let's find our angle. So we've got our cast diagram, guys, and we're looking at tan now. So if you go back to the original cast diagram, it's this quadrant and this quadrant that we're looking at. So 61.5. Let's just leave it to 1 dp. So we've got 61.5. So if we're going around, remember this way, it's 180 plus the x. So it will be 180 plus 61.5, which gives me 241.5. And obviously our new interval is up to 433. So that's going to be one round up until the next one. So if we actually did this earlier, didn't we? We've got it here. So if we go around all the way, and this is going to hit 450 at this point. Yeah, so 433. So we can go one more round. Okay, so we're going to do 360 plus the 61.5, which is 421.5. So what we actually ended up with, we've got x plus 73 equals to 61.5, 241.5, and 421.5. So do our final solutions. So we've got x, so we're going to take away 73, guys. So we've got 168.5 and 348.5. Why did I only end up with those two solutions, guys? Because 241.5 is 168.5, and then 421.5 minus the 73 is 348.5. However, 61.5 minus 73 is going to give me a negative number. The problem with that is here. Initially, for the solution of x, we only want it between 0 and 360. And obviously, if we end up with a negative, it's lower than 0. And we want anything which is greater than or equal to 0. So we end up with only these two solutions. Okay, right. Let's look at one last example. If I have a third cos x minus 67 is equal to 0.23. So again, it's the same concept as solving an equation. You want to make x a subject. So we divide through by a third. So it's going to be cos brackets x minus 67 equals to 0.69. Okay. And then you're just going to do x minus 67 is equal to cos minus 1 of 0.69. So x minus 67 equals to 46.4 degrees. Now, we need to change our interval. That's one thing we cannot forget. So we've got between 0 and 540. So our new interval we're looking at is between minus 67, because we're looking at x is minus. So that's going to be 473. So let's draw our cast diagram. We're going to end up with cosine is positive in these two quadrants. So it's 46.4 and 46.4 in these two. We've got 46.4. We're going to do 360 minus 46.4, 313.6. And then because our interval is 473, we need to go around one more time. Because if we recall from earlier, we go up to 450. So that is within the interval. So it's going to be 360 plus 46.4, which is 406.4. So our solutions for x minus 67 are 46.4, 313.6, and 406.4. But we haven't found out what x is. So we're just going to add on the 67. So we end up with 113.4, 380.6, 473.4. And that's our answers. So what about when we use trig identities to solve equations. These ones are going back to our trig identities, which we've introduced. We have sine squared plus cos squared equals to 1, and tan x is sine x over cos x. So using these two, we're going to combine the two. So we're going to use the identities as well as using the class diagram to get our solutions. So the following question: show that the equation 4 sine squared x equals to 3 minus 3 cos x can be written as 4 cos squared x minus 3 cos x minus 1 equals to 0. So this is just our basic manipulation. So when you have 4 sine squared x equals to 3 minus 3 cos x. Now, for me personally, I would start with the left-hand side because obviously my end goal is to get everything in terms of cosine. So let's manipulate this side over here. So we're going to have 1 minus cos squared x. A quick gentle reminder. We have sine squared x plus cos squared x is equal to 1. So if we want to find what sine squared x is, 1 minus cos squared x. Okay, so just plugging that in. So 3 minus 3 cos x. And note that this is not an identity because it is an equation, because it only holds for certain values of x when you substitute them in, as is given in the question. So 4 minus 4 cos squared x equals to 3. So it's just algebra basically, guys. We're just expanding it out. Now here we want the coefficient of cos squared to be positive, so we're going to move everything onto the right hand side. So you end up with 4 cos squared x minus 3 cos x, and then you do 3 minus the 4, which is minus 1 equals to 0. Okay, and that's our end goal. So that's part A done. Now part B asks us, hence solve the equation 4 sine squared x equals to 3 minus 3 cos x in the interval 0 to 360. Now the good thing is, if you are ever stuck on part A on how to manipulate the trig identity, the really good thing is that you can still answer part B even if you don't know how to do part A, or if you're not feeling comfortable, and you can always come back to it later because they've actually told you what your end goal actually is in part A. So using what we've got worked out, so let's do 4 cos squared x minus 3 cos x minus 1 equals to 0. Now at this stage, guys, you can recognize that it's a quadratic. Personally, I prefer to change cos x just for ease of working out. So I'm just going to say let cos x equal to y, and I'm going to plug that in. So 4y squared minus 3y minus 1, and I just find that much nicer to work with, much more simpler. So you're going to end up with two brackets. So you've got 4y squared minus 4y in one bracket, y minus 1. So I'm just going to use the AC method. So AC method is two numbers that multiply to give you 4 times minus 1, which is minus 4, and add together to give me minus 3, which is here. So I end up with minus 4 and minus 1. So you end up with 4y squared minus 4y. I mean, guys, there's different methods, but I'm just going to use the AC method. So once we got to this stage, we factorize out the 4y. So you end up with y minus 1 plus 1, y minus 1 equals to 0. So you end up with 4y plus 1, y minus 1 equals to 0. So you end up with two solutions, y equals to minus a quarter or y equals to 1. Okay, now remember we said that let cos x equal to y, so we're going to plug it back in. So we've got cos x equals to minus a quarter, so x equals to, if we use our 104.5 cast diagram, and 254, so 255.5. Once we've got that, let's look at our second solution. So cos x equals to 1. Now this one wouldn't make sense to use a cast diagram, so let's just do a quick gentle recap on this one, what we did earlier. So obviously we found cosine is negative, so it's going to be in these two quadrants, forming the acute angle. So 104, so 180 minus 104.5, so that gives you 75.5 there and 75.5. So it's just 180 plus the 75.5 is 255.5, in case you're not sure where I got those two values. Now here, cosine, in your calculator, if you actually did it, you would get 0. Okay, and that's one solution, and 360 is the second solution. Where have I got that from? Now this is from the cosine graph. Okay, I'm just going to do a quick sketch here. Now, the cosine graph has a maximum point of 1 and the minimum point of -1. Apologies, it's far from being to scale. But so what we've said is that when x is 0, it equals 1. And the next point on the cosine graph, when x is equal to 360, is when cos x equals to 1. Okay, so the two solutions are 0 and 360 from cos x equals to 1 and 104.5 and 255.5. So those are our full solutions. Right, let's do one more like this. So we've got 3 cos x minus 2 sine squared x equals to 0. So you have 3 cos x minus 2 brackets. We're going to substitute again. We're going to try and get it all in terms of cosine. And the reason why is because I can just see easily manipulating the sine square to get it in terms of cos. So again, using the same principle as before, 1 minus cos squared x equals to 0. So what we did here, where we remembered the trig identity from here, we're going to do exactly the same. So 1 minus cos squared. And then you just expand the brackets, 3 cos x minus 2 plus 2 cos squared x. So once you've got this, you've got 2 cos squared x plus 3 cos x minus 2 equals to 0. We're going to do exactly the same thing as before. Let y equals to cos x. And we'll just make it much easier to work with. 2y squared plus 3y minus 2 equals to 0. Again, I'm just going to use the AC method very, very quickly. So AC equals to minus 4, B equals to 3. So I end up with two numbers that multiply together to give me minus 4, add together to give me 3. So that will be minus 1, and so minus y, and 4y. Okay, and we're going to just factorize out each bracket. So you end up with 2y minus 1 plus 2y minus 1 equals to 0. So y plus 2 and 2y minus 1. So once we've got that, our two solutions are y equals to minus 2, y equals to 1/2. But remember, we said that let y equals to cos x, so we're going to plug that back in. So cos x equals to 1/2. So x equals to the inverse of cos, which is just 60. Using our cast diagram, so we know that cosine is positive in these two quadrants. So 60 and 60 here. So our second solution is going to be 360 minus 60, which is 300. So our two solutions are 60 and 300. Here, unfortunately, if we plug in cos x equals to minus 2, we know from the graph that I mentioned here, the maximum point is 1. Hence, this one has no solution. So there you go, guys. That's how you solve different trig identities using the cast diagram. So let's just brief overview. We've got an introduction to the cast diagram, then how to actually find solutions using the cast diagram, and then we looked at examples of how to change the intervals, and then finally we looked at manipulating trig identities and then finding solutions using the cast diagrams. I hope that was useful. See you in the next video.